Alright, so this is the video that accompanies your lab for Module 4. And what we're going to be working on today is measuring moisture in the atmosphere. Now, something you may have noticed as you go through life is that if you go to the refrigerator and pull out a cold soda, or if you're over 21, a cold adult beverage, you may notice that as you pull this out, all of a sudden you see that the water forms on the outside of your cold beverage, and you might have wondered where this comes from. Well, the answer is it's in the air, and there's always moisture of some amount in the air. The question is how much or how little, and the measure that meteorologists use to determine how much water is in the air is something called the dew point temperature, and that's what we're going to be measuring here during this first part. And this is for part 1 then of your experiment. So what I've got here again is a setup, pretty simple. I've got a glass with water in it that's a little bit warmer than room temperature water. It's you can see the glass is completely clear here. There's nothing crazy going on the outside of it. It's totally dry. And I've got my thermometer again from the second experiment that we did. Okay, so what we're going to do first then is get the room temperature, and in this case it appears to be 72 degrees Fahrenheit in here right now, or 22 degrees Celsius. Okay, so that's going to be the first thing that we need to know in order to determine, well, we don't need to know it to determine the dew point temperature, but a little bit later on when we start to talk about relative humidity and other things, we need to do that. So what we're going to do here is we're going to put this into the water and let it adjust, just like we did before. Okay, and as I said, this water is a little bit warmer than room temperature, but not too much warmer. I just took it out of the tap. Okay, so here we have, right now, a temperature of 28 degrees Celsius, okay, and for those of you who are converting, that's about 82 degrees Fahrenheit, a little bit warmer, like I said, than room temperature, but not terribly much so. Okay, so what I'm going to do now is I'm going to add, very slowly, ice to this, and I'm going to continually stir it, and the ice is going to melt, and it's going to cool the water in the cup off, and then eventually what you'll see, well, something magical will happen here as we go down and do this. So, okay, so I'm going to start adding little chunks of ice to this and stir it, and that will cool off things, and I'll let you know what the temperature is as we continue to do this. Add a little bit more than that. Okay. So the ice melts pretty rapidly right away because the water is pretty warm. Okay, we'll keep on going here. Don't want to add the ice too fast or then things kind of get out of control here. So I want things to go a little bit slowly. Usually, like when we do this in the lab, we'll do it with a metal can because the metal can stays the same temperature as the water inside of it does, but I'm using the glass here because it's easier to see. And for the purpose of the video, it's a little bit easier to see what's going on. Okay, so continue here. Okay, we're still not cooling down all that rapidly, so I keep adding more ice here. Nice big one there. So. Okay, so be a little careful so I don't break my thermometer. That's always the danger with these glass thermometers, is eventually they want to break. Okay, so the temperature of the water here slowly but surely is getting down close to room temperature. Remember that was 22 degrees Celsius. Just a moment ago we took that. Keep adding ice to this. Little chunks of ice. Okay, so keep going here. And we want to stir it for a couple of reasons. First of all, it mixes all of the heat inside of the glass up, and secondly then it also communicates that heat to the walls of the glass, because when we see something happen here, it's going to happen outside of the glass, not inside of the glass. Okay, so our temperature right now, well, we're down to 22, so we're down to room temperature here at this point in time, and we'll continue cooling now. So I don't know exactly when the magical thing is going to happen here, but it will happen at some point. We'll keep on stirring and cooling this off. Okay. Okay, so we're down to 20. And there's 18 degrees Celsius. Keep on stirring, keep on putting ice in here. Again, this is something you can certainly do at home if you have a thermometer, which is not always the easiest thing to have. The good news about this particular experiment is that you could use even a thermometer like the kind you'd use to see if you get a fever. You don't need anything fancy, you know, it doesn't need to go up all that high. In this case, and little chunks of ice here. We'll keep on going. Okay, so our temperature right now of our water is 17 degrees Celsius. We'll keep on stirring here. Continue to cool off. And what we want to be watching here is the glass itself. At some point, something's going to happen to the glass. Keep on going here. Need stirring music of some form, but I won't ask my assistant to do that because you never know what you would get. Okay, so we'll keep on going here, and going and going and going. Okay, and we're down to 14 degrees Celsius now. So we're getting quite a bit colder than room temperature at this point. Add a little chunk of ice here again. Keep on going here, keep on going. Okay, we're down to 12. I would expect it would happen pretty soon here. And yet. Switch hands here, just test. No, it hasn't happened yet. I'm going to win the Oscar this year for making the most boring videos ever. Okay, now, you look very carefully at the glass. Maybe we can bring the camera around over here, just sort of shine it around the camera. The temperature right now is 10 degrees Celsius. You can just look carefully at the glass. What you'll see is, bring it over here. Is it loose?
Yeah.
Okay, so I'm just going to bring the camera over here and look. If you look at the light on things there, what you can see is, if I go like that, you see where I've done that? It's not clear anymore. Okay, it's a little bit foggy. What's actually happened here is water is condensed on the outside of this glass. Okay, so the temperature of the glass is 10 degrees Celsius, and water condensed on the outside of that glass. Okay, so what we would say in this situation then, that the dew point, the temperature at which condensation occurs, is 10 degrees Celsius. Okay, so given that, you can go on then. That'll allow you to finish problem 1 of part 1, and you can continue on then and work on the remainder of your experiment. See you later.